Hi everyone, this is Ruth and welcome back to my channel. This channel is mainly about my home lab where I build different setups, test networking tools, and experiment with infrastructure projects. My main goal with this lab is to practice cybersecurity skills in a real environment. So over time, I'll be building out different systems, security tools, and monitoring platforms. Today, we're continuing our Cybersecurity Lab series by deploying Kali Linux into our VLAN environment and using it to simulate real-world reconnaissance against a Windows server through pfSense. We'll start by downloading Kali Linux from kali.org. We'll head over to the Installer Images section, choose the x86-64 installer image, which simply means the 64-bit version for modern systems, and download the ISO file. Once the download is complete, we'll move over to Proxmox VE and upload the ISO into local storage using the upload option. We'll wait for the upload to finish before moving on. After that, we'll create a new virtual machine. We'll name it Kali-VLAN60 so we clearly know this machine belongs to our attacker network. We'll select the Kali ISO we just uploaded, enable the QEMU agent, and keep most of the settings as default. If you want, you can increase the disk size. In this setup, we'll use 60 GB. For CPU, we'll assign 3 cores, and for memory, we'll set 6 GB so the system runs smoothly during scans and tool usage. Now, for the network configuration, this is very important. We'll set the bridge to VMBR1 and assign VLAN tag 60, which represents our DMZ or attacker network. We'll keep Kali isolated in its own segment. After reviewing the configuration, we'll click Finish and start the virtual machine. When Kali boots, we'll choose Graphical Install, then select our preferred language and keyboard layout. Next, we'll move on into network configuration. But here, we immediately hit an issue. DHCP fails. This happens because pfSense is not fully active yet, or the VLAN routing is not ready, so the system cannot obtain an IP address. To fix this, we'll go back and start pfSense, which acts as our firewall and routing system. Once pfSense is running, we'll retry the DHCP configuration, and this time it should work properly. We'll continue the installation by setting a hostname, username, and password. Then we'll move on to disk partitioning, where we'll select guided use entire disk. We'll confirm write changes to disk because this is a clean virtual machine and we want a full installation. After that, we'll leave the software selection as a default and allow the installation to complete. Once finished, we'll reboot the system and log in using the credentials we created earlier. Now inside Kali, we'll open the terminal and run IPA. This allows us to confirm that the machine is correctly assigned to VLAN 60. Next, we'll test internet connectivity by pinging Google DNS. Once that works, we'll update the system using sudo apt update and sudo apt upgrade -y flag. The -y flag simply means the system automatically confirms all prompts during installation and updates. Now we move on into the interesting part, reconnaissance and network discovery. We'll identify our target, which is a Windows server located on VLAN 70 with the IP address of 10.0.70.2. Now, from Kali, we'll use Nmap with the SS and SV options to perform a stealth scan and detect running services on the target system. By the way, a stealth scan works by partially initiating a connection without fully completing it, which makes the scan quieter and more difficult to detect compared to a normal connection. This allows us to identify open ports while creating less lagging and making the scan quieter than a normal connection attempt. The -SV flag performs service version detection, which means Nmap attempts to identify what services and versions are running behind the open ports. At first, the scan fails and suggests using the -PN flag. This happens because the host discovery ping is blocked by firewall rules. So Nmap assumes that host is down. We'll try again adding the -PN. But after waiting for a while, we still don't get any results, so we stop the scan. Next, we'll go into pfSense and check the firewall rules on the VLAN 60 interface, which is our attacker network. We notice that there is a black rule for RFC 1918, which is it's a private networks. This rule is designed to prevent access between private internal networks by default. But in our lab, it is also blocking communication between VLAN 60 and VLAN 70. To fix this, we disabled the RFC 1918 blocking rule. This allowed traffic between our VLANs to pass through pfSense according to our firewall rules. Now, let's return to Kali and let's run the scan again. This time, it works perfectly, and we can finally see open ports and services running on the target Windows server. This confirms that our VLAN segmentation, routing, and the firewall configuration are all working correctly. At this point, we now have a fully functional cybersecurity lab where Kali Linux acts as the attacker, the Windows server acts as the target, and pfSense controls all communication between them. This setup allows us to safely simulate real-world reconnaissance techniques, study network behavior, and better understand how enterprise environments are structured and secured.